Okay, we're on number 24. It's the last problem in the problem set. And again, these problems, I saw a long, very long video from Black Pen, Red Pen, who did all 24 limits in one YouTube video, by the way. What am I doing? I'm typing up what my work would look like, typing up definition, my definition would look like, and posting videos for each of the problems over here. And this is the 24th one. All right. If you want to watch Black Pen, Red Pen's video, it's certainly available, and it's linked in this document, by the way. I want to go to the whiteboard, though, and I want to talk through the problem. This is number 24. As I do it, though, I can kind of remind you of certain things that you've done in pre-calculus, and we're doing the limit as x goes towards infinity of x squared, x plus 1 is infinity. By the way, that stands to reason, looking at it, x squared grows much faster than x plus 1. You're expecting is going to go up to infinity. I want to review some of the things you did in pre-calculus, though. So f of x would equal x squared over x plus 1. Your teachers in pre-calculus told you if the degree of the top was greater than or equal to the bottom, do a long division, see what happens, by the way. Let's take a look at this over here. And I'm going to take x plus 1, and I'm going to divide it into, I'm just reviewing pre-calculus, by the way, x squared. What do you get there? X, because x times x is x squared, plus x. You're going to subtract, you get minus x. What do you get there? Minus 1. That would give you minus x minus 1, which would give you 1 as a remainder. So this thing also equals x minus 1 plus 1 over x plus 1. Let me get my eraser out, get rid of the long division. I don't need it anymore. But I do want to check it. And if I checked it, pulling them together, you get x squared minus 1 plus 1, which is x squared over x plus 1. Yeah, it works out pretty nice. So what did the teachers do now in pre-calculus? They did this over here. They put the asymptote down, and it's a slant asymptote. And the slant asymptote is this thing right over here. And what's that going to be? Y-intercept of minus 1, x-intercept of 1, and it looks like this over here. All right, the next thing they probably would have done was there's also a vertical asymptote. And the vertical asymptote is going to be where x equals minus 1. All right, why is that? Division by 0. So I put this over here. And that's the vertical asymptote. So the slant asymptote is y equals x minus 1. The slant, that's the slant asymptote. The vertical asymptote is x equals minus 1. Division by 0, by the way. And is there an x-intercept? There is. It's like if you plug a 0 in, what would you get? You'd get 0 on top and 1 on bottom, which is 0. And that's really the x and the y-intercept. All right? So that's not too bad. All right? What do I have? I have two asymptotes down, and I got a point. And what do you do now? Sign analysis. I'll go through that with you. The sign analysis, I'm looking at it. I'm going to say minus 1 is not in the domain of the problem. The other place where it takes on a 0 is at 0. Take some simple sign analysis. And what's a good sign analysis to use? After 0, after 0 would be like 1, plug it in. You get 1 over 2, which is a positive number. Boy, that stands to reason, by the way. I'll point out what I mean by that. It's going towards this line over here. Positive. Well, that's convenient. Now between, let me just go over here. I'm going to put this over here now. Something like that. Yeah, it's not the best looking picture, by the way. Now I'm wondering between minus 1 and 0, what's a good test point? I'm going to say like minus a half. And if you plug it in, what would you get? On top, you get a positive number. On bottom, you get a positive number. And what's that going to be? That's going to be a positive number. All right? So I'm going to say, maybe something like this now. I think you get the idea, right? Now, what am I going to do over here? I'm going to take a point below minus 1, like minus 2. It's a test value. Plug it in. The top is positive, bottom's negative. So overall, it's negative. So I'm going to maybe say something like this over here. This is my rough pre-calculus sketch. What do I know? As we go towards infinity, this thing's sailing straight up towards infinity. All right? Okay, so we got that part covered. And my pre-calc skills, I mean, not the best looking picture, by the way, but it's good enough at this point. All right, it's good enough. We could refine to using some calculus techniques, but we're not really interested in that. I'm just interested in like pre-calculus, yeah, at least to infinity at this point. So what I want to do now, get my eraser out. I'm pretty comfortable with this over here. And what I want to do is talk about the proof of it, right? Because we just went through some simple verification over here. And this is problem number 24. So in problem number 24, what I'm looking at an MN definition, all right, for this proof. So let's write this down. Given, we're given that we have some M greater than 0. We need now to choose an N. I don't know what the N is, but it will be in terms of M at some point. All right, I just don't know what it is. I can't know that by looking at it. When I go down now, suppose I want to point out X a positive number, and I'm going to say X has to be greater than whatever the N is at this point. And the problem is I'm going to say this is going to be a positive number. We're going towards infinity, by the way. Seems reasonable. And then I got to do the check part. And the check part's always the toughest thing for me to look at. What do you get over here? X squared, X plus 1. I want to point out this is going to lead to an M at some point. Now, I understand that it will lead to an M, but I don't see that right away. So the first thing I want to write down is I want to start to, get these things to be bigger than the next thing. So I'll put this over here. Then I'm going to write this X squared down. And then I'm going to put X plus X down. All right? So this is why you're doing that. I'm looking at it, and the tops are not the one thing that bothers me. It's the bottom. And if this is true, by the way, I need to make sure that X plus X, right, is going to be this. Like, I need to make sure of that. So then the question comes, if that's what I'm trying to do to make that inequality hold, what I'm looking at is I'm really looking at 1, and I'm looking at this over here, because I took X from both sides. Now, unfortunately, in my supposed part, I put down that X is greater than 0, but now I know X must be greater than 1. I'll put this down now. All right, now let me keep moving on. I'm going to write this down now. This is equal to X squared over 2X, which, if X is greater than 1, I can reduce that. That would just be X over 2. All right, that's not so bad. Now, I'm looking at this thing over here, and I'm wondering, can I put an inequality down? And I think so. I'm going to write down N over 2. And X is greater than N, so X is greater than N over 2. And now I got it. What do I have? N over 2 is equal to M. And now I got to figure out what the N is. And what's N going to be equal to? 2M. We are now done. And we're going to write down QED. Again, I want to remind you these problems that come from a red pen, black pen. And red pen, black pen doesn't say QED. I'm sorry, I call them red pen, black. I'm sorry. It's black pen, red pen. He puts a little square box down and shades it in. But we're done with the question. Thank you.